Hello and welcome to another podcast, Fresh Thinking by Snowden Optiro. My name's Ian Glacken. I'm an executive consultant here at Snowden Optiro in Perth, where it's a nice warm summer's day. This is part two of a two-part podcast, and I'm here with Dr. Greg Zhang, and we're talking about the use of CNNs, or convolutional neural networks, and machine learning with a specific application. And that specific application is the use of dense grade control data to infer or impute information where we have sparse data, like a resource estimation data. And in the first part, Greg explained how it works. And we're just going to explore this issue a little bit more. So welcome again, Greg.
Thank you, Ian.
So let's talk about this idea of iteration and how our CNNs or our machine learning is ongoing. How does that work?
Right. So this is very crucial that it should be an ongoing process, just like the mining itself, that as you mine deeper or extend laterally, you would gather more and more grade control data. And if you stop learning after the first few benches, then basically you're throwing away the information that could be used to refine the model. It's a similar logic that when we do the traditional geostatistics, that when it comes to the estimation stage, that we usually wouldn't make the full use of the multivariates, just geochem or the lithology or any other alphanumeric values. Whereas in this case, we could make the full use of those information. But going back to here, so the workflow is more like at the initial stage, we could train the CNN on the first couple benches or zones with grade control data and then generate the predictions for the areas without grade control. Then as the new grade control data become available, then we could get the new data. Now we have a larger overlay between the resource model and the grade control. We could update the model or update the learning itself. Then we could either retrain the CNN from scratch with an enlarged data set, or we could use a technique like the incremental learning to update the model. Then the mapping would improve because it just sees more geological contexts, more spatial patterns. And then in the last, we could re-predict the remaining area, then applying the refined CNN to the still unmined regions, and the planning and reconciliation get progressively better or closer to the truth. Then loop this workflow and continue over the life of a mine, and this model becomes more knowledgeable as the operation progress.
Right. So given that we typically estimate resource models on a wider spacing in time than the grade control models, what we're talking about here is a dynamic process that is always learning or being updated by infill drilling.
Exactly. And then that's particularly powerful for the multivariate situation. For example, we get polymetallic deposits or where the metallurgy, hardness, and the grade interact. The CNN can capture complex relationships, and which is the power of this method, across variables and across rock types that are really hard to express in the simple linear methods or the global correction factors.
Okay. So we did talk in the first podcast about the idea that this is not a push button or a automatic solution, and there are issues. So what are our practical considerations, Greg, in applying these techniques?
There are few. So the first is data quality and alignment. So we need to carefully align the GC data with the resource model and make sure our GC samples are composited or reblocked in a way that consistent with models, the block support. And then we need to ensure that coordinate system, for example, the bench elevation, domains, they all line up. And then we should deal with any bias. For example, the grade control model may not sample all the rock types equally. Then the second will be we should have enough training data. So CNNs are powerful, but they need enough examples. So if our GC area is extremely small, then maybe we should simplify the problem and maybe don't get too much data in there and ask the CNN to learn the very complicated patterns. Then we could use a 2D slice instead of full 3D kernel, and we could start with fewer input variables or use more regularized and simpler architectures for this learning. Then we could we could set up a validation strategy. So you can't just train on the whole overlap area and declare victory. So we need to hold back part of the data for the validation purpose.
And this is quite a common technique in data science where we create a model and we use a set of data, but as you say, we keep back some of the data and we test it we test the model in an area where we do have the data.
Exactly. We in the data science, people call that bootstrap or cross validation. In geostatistics, we occasionally call that jackknife test. But overall, they use a similar logic behind. And then it's interpretability and trust. So the critical piece is keeping the geologists and engineers in the loop. So the CNNs is not replacing their judgments. It's more like a tool. Anyone can use that. So you could use this to visualize the difference between CNN adjusted prediction and the original resource model and look for the geology explanations where deviation are systematic. So we are geologists. Whenever we see this consistent bias, we could try to think from the geology perspective. Then we could use domain knowledge to sanity check the model. And if needed, we could adjust the inputs and architectures. And in the end, it's not just a single estimate. We could make it multiple versions, and this is a similar logic as our traditional simulation. You get multiple versions of this estimation, then you can ensemble them, and then you could start to think about uncertainty or risk analysis.
Okay, so let's just examine two more issues that you talked about earlier on, this idea of lithology and categorical coding.
Yep.
And then the second issue is this idea of multivariate, where we got multiple elements or variables. How's that going to work?
Right. So traditionally, a lot of reconciliation done is on the single metal or say gold grades and maybe one or two domains. But we know that grade behaviors strongly depend on the lithology, alteration, structure, or maybe some other rock properties. So when we build a CNN model, lithology code can be added as an input channel. So the network can learn, for example, say, in this lithology, the resource model tends to underestimate the grade in the hanging wall, while in the other lithology, it overestimates nearest contacts. Then we could also input multiple metals simultaneously and treat copper, gold, silver as separate channels. Then the model can learn those joint patterns and like how high grade copper might correlate with changes in gold or sulfur in certain rock types. So this multivariate and categorical context is a big advantage. You're not just learning the resource model is 10% wrong, but you're also learning where and why it could be wrong. It tends to be wrong. So in a way that conditional to the geology. So that makes the prediction in the unmined area richer and more physically plausible.
Okay, good. Okay, so we've talked quite a bit about this, Greg. I guess people out there might be thinking, sounds good. So if they wanted to look at using these techniques, how might an operation get started in this area?
So I would break down that into a couple steps. The first is choose a well-documented zone, that a pit or a panel where you have very good GC coverage and reasonably up-to-date resource model. And then make sure the geology model and coding are consistent, between the two sets of the models. Then second, I will assemble a very clean data set. So no matter what type of techniques we use, those are the fundamentals. You always need a clean data set. Then you would extract the block model variables, extract the GC data, and then trying to aggregate everything inside one model. And then third, we could define the prediction target. So decide if we're going to just predict the GC model, or we're going to or predict this correction factor or the probability above certain cutoff. Then we could start with with one main commodity, and then we could keep it simple, then add some more complication on top of that if we are confident. Then we could build a prototype CNN model, and then once we're happy with that, we validated it well, then we could start to compare the CNN model against our traditional model, which we know the backend. If it works, why, and if it doesn't work, we also understand why. Then we could use that as a bridge for learning. Then we can plan this iterative loop and plan for the ongoing process.
Okay. So we've talked about a few things in this podcast and the last one. So let me see if I can wrap it up for you and for the audience. So we're talking about a situation which is very typical for a lot of mines, where we have a resource model, a long-term model built on fairly wide-spaced data, and at the same time we have operational area, which has a grade control model, and that grade control model is characterized by dense data and also the collection of additional data like mapping or multiple variable or categorical information or whatever. And we talking about using CNNs, convolutional neural networks, to look at the relationships between the detailed mapped grade control area and then apply that information to the sparser data. And the other thing you talked about, Greg, was this idea of iterative updating. In other words, as we go deeper through our mine, we collect more data, more grade control data, more mapping, more categorical information. We're updating our predictive model. And you also talked about this idea of using multivariate information, if that's going to help us, or if we're in a multivariate situation, and also this idea of using categorical variables. So have I got all of that information, or is there anything else we need to think about?
That's a great summary. I will just add one final thought, that machine learning in resource estimation shouldn't replace geologists or
very important
engineers. It should augment them. CNNs are powerful pattern recognizers, but they still need good data, very thoughtful validation, and domain expertise to interpret and act on the results. So when those pieces come together, you can turn the GC data you're already collecting into a smarter, adaptive resource estimation process.
Okay, great. Thanks, Greg. That was very interesting. And thank you for listening to another episode of Fresh Thinking by Snowden Optiro. If you enjoyed that, there's lots more information around, or contact us. Or if you want to hear more of our podcast, just please subscribe to where all good podcasts are found. Thank you.
Thank you.